Have you ever felt the ground beneath your feet shaking uncontrollably? It's an experience that can be both fascinating and terrifying. You're minding your own business, and then suddenly, the world starts to tremble. The ground beneath you, usually so solid and reliable, becomes as unstable as the ocean waves. It's a sensation that leaves a lasting impression, no matter how big or small the quake. Well, if you've experienced an earthquake, a natural phenomenon that has intrigued scientists and common folks alike. But what exactly causes these earthquakes? What makes our seemingly solid Earth shake? Well, to understand earthquakes, we first need to understand the structure of our planet. Earth is like an onion, composed of different layers. The outermost layer, which we live on, is called the crust. Beneath the crust, we have the mantle, and at the very center, the core. Now imagine the crust as a giant jigsaw puzzle, but instead of pieces, we have what we call tectonic plates. These plates aren't static, they're constantly moving, albeit very slowly, on the semi-fluid mantle beneath. They slide, collide, and grind against each other at snail's pace. We're talking about movement as slow as your fingernails grow. It doesn't sound dramatic, does it? But remember, we're dealing with colossal plates of rock here. Let's use a simple metaphor to understand this better. Picture two massive icebergs floating in the ocean. As they drift, they might bump into each other, scrape past, or even get stuck. This is similar to how tectonic plates behave. The points where they interact are known as fault lines. Now, when these plates try to slide past each other but get stuck, stress builds up over time. It's like a colossal game of tug-of-war. And we know in a game of tug-of-war, something eventually gives. In the case of our tectonic plates, when the stress finally overcomes the friction holding the plates in place, it releases a huge amount of energy. This energy ripples out in waves, shaking the ground, and voila, we have an earthquake. But it doesn't end there. The energy keeps moving, rippling out in all directions like ripples in a pond. These seismic waves are what we feel during an earthquake. The stronger the waves, the more intense the shaking. So the earth beneath us isn't as still as it seems. It's constantly shifting and moving, and sometimes we feel it as an earthquake. Quite a lot to take in, isn't it? Let's quickly go over the main points to make sure we've got everything. First off, we dove into the structure of our planet. It's not just a solid sphere, but rather a complex system of layers. A crispy crust, a hot and flowing mantle, and a superheated core at the center. This crust, where we live and build our cities, isn't a single piece, but rather a jigsaw puzzle of tectonic plates. These plates, we've learned, are not stationary. They're constantly on the move, albeit at a pace slower than a snail's. They glide, grind, and occasionally clash on top of the Earth's semi-fluid mantle. It's this movement, this tectonic dance, that's the real culprit behind earthquakes. When these plates collide, pull apart, or slide past each other, they cause the ground to shake, creating what we experience as an earthquake. The energy released in these moments is immense, sometimes enough to topple buildings and reshape landscapes. It's a reminder that our planet is an ever-evolving entity, a living canvas painted by the forces of nature. We're passengers on a world that's constantly in motion, and sometimes, just sometimes, we feel that motion in the form of a quake. Have you ever encountered an earthquake? Share your experiences with us. If you enjoy our content, don't forget to subscribe to our channel.